Assalamualaikum everyone. I hope you guys are doing well. So let's start with the add maths logarithms chapter. It's not a difficult chapter, but students generally find it a little bit challenging because it has a little bit more difficult questions or tricky topics to encounter. But overall, if you get a grip of it, if you had a whole of it, it's really easy to understand. It's really easy to inculcate with your system. you know so let's start with some basic examples which you have encountered most probably in O level IGCSEs or GCSEs or Edexcel or whatever board you're studying in. So just start with a little simple problems. For example, 2x is equals to 4. We can also write it as 2 is equals to 2 square. If the bases are equal, we can also equate the powers. So x is equals to 2. It was a really simple thing, but we are going to build upon this concept. Now, so proceeding further, 2x is equals to 16. Well, we can also write 16 as 2 raised to the power of 4. So it comes out to be x is equals to 4. When the powers are same, when the bases are same, we can equate the powers. These are the simple laws of indices which you have encountered in O levels, and I really hope you have a hold of them. So let's proceed with 6x to the power of 6x to 776 is equals to 776. Well, we can write 7776 as 6 to the power of 5. you know so x comes out to be approximately 5. 4x is equal to 16. Well, we can also write it as 4 raised to the power of 2, and x is equals to 2. Easy peasy. So 2x raised to the power of 16777 to 16. Well, it took me a while to catch that. So 2x is equals to 2 raised to the power of 24, and x is equals to 24. So these were the simple cases. Well, we can also catch this concept and we can carry this concept further. So let's see if we are able to succeed, or what will be our odds of success. So can we write 41.6 as applied to the 2 the power of something? Can we write it as that, or can we use that concept? Well, I don't think so. You cannot write 2 raised to the power of x, y, z or something, which we can equate the power. You can equate the bases on the left hand side and the right hand side, and you can equate the powers. Well, it doesn't work like that right here. So what are we going to do now? So these are the beautiful cases where laws of logarithms come in handy. Logarithms come in handy. These are the cases. These beautiful cases are where logarithms come in handy. Logarithms. So what do? We use the laws of logarithms. Well, we can write it as a form of with log with the base of 2, argument of 41.6, which is equals to x. Well, I don't expect you to catch it in the first instant, so we'll break it down later. But the key thing is to understand what does this statement refer to, or what does this statement mean. So here the 2 means base. Well, let me use a different color. I don't want you to get confused here because of the color matching. Yes. Well, and what does this 41.6 refer? Well, it refers to the argument. It's called an argument. Okay? So it's called a beautiful argument. So overall, the base of 2 with the argument of 41.6, log with the base of 2 with the argument of 41.6. So there are some conditions which I expect, which I want you to learn and which I want you to memorize. The bases can never be 1, can never ever be 1, can never be negative. And similarly, arguments can never be 0 or negative. Okay, so they can never be negative or they can never be 0. So you have to memorize these. So how do you select this at the calculator? Well, you can go to the logarithms tab which you have in your calculator. I expect you to use a modified calculator. Well, even in a typical calculator, you might have this feature. You must have these features, and expect your calculator to be a little more efficient. This button or this function or this operator is for the log, and I expect your calculator to at least have this. So you can solve it and you can get your answer. Well, let me solve this for you. I don't want you to do the hard work. So it comes out to be 5.37. All right, 5.3785. So which basically this statement applies, or this answer applies, that 2 raised to the power of 5.3785 is equals to 41.6. So this is basically what the statement applies. So logarithms basically help us to determine the powers in decimals. We cannot expect 41.6 to write, we cannot expect to write 41.6 in terms of the powers of 2, because that's just not how it works. Well, you can do that, but it will take you ages, and I don't think advanced paper is can give you the freedom or can give you the freedom to think about that. So the 2 raised to the power of 5.3785 gives you the answer of 41.6. So logarithms help us to determine the decimal powers. Okay. So basically in O-level basically in O-level GCSE or Edexcel or OCR or whatever you've been studying lately, in the topic of indices, in the chapter of indices, you have encountered a certain part of logarithms, or you can also say that logarithm is nothing new, it's nothing special, it's just an extension of what you learned in indices, of what you practiced in indices, or the laws of indices with a little more broader spectrum are called logarithms. So you have been encountering logarithms, but you just didn't know it. In the easy words I can, these are the most easy words I can put in, you have been studying logarithms your whole life, or your whole O level maths and indices in the chapter of indices, but you just didn't know. So logarithms are nothing new, they are nothing special, they are basically an extension of indices. So 8x is equals to 656. So how do we write this, or how do we solve this? We cannot write 656 in the powers of 8. Well, you do not, basically take my advice, don't even try to write in the power of, or just don't even try to make their bases same, please, just don't. Because if you want to make the bases same and then you're going to equate the powers, it's going to take forever. So just use logarithms. Keep your brain a little bit calmer, do not stress too much, just use logarithms and keep your head as easy as possible, you know so how are we going to use logarithms? How did I convert from this simple statement, from this simple question, to this logarithmic expression? So we are going to see that. So 8x is equals to 656. So the first step which you must follow is write log on right hand side and follow the arrow pattern. Now what is the arrow pattern? Well, we're going to dive into that. Arrow pattern. 8x is equals to 656. So we write logs on the right hand side and see this carefully. X is going to replace 8 and 8 is going to become the base of log. And argument will be our 656. So log with the base of 8, argument of 656 is equals to x. This is our basic answer, or this will be our expression in logarithmic terms. Well, to grab a better hold of it, we can also go a little deeper. 7x is equals to 56. Well, x replaces 7 and 7 goes to the right hand side and becomes the base of the log on the right hand side, which we are going to introduce. So log with the base of 7 with the argument of 56 is equals to x. So let me repeat it once again. Write log on the right hand side. It's very important. It's, you have to think of it. You have to come with it. Write log on the right hand side and follow the arrow pattern. So our log comes to the right hand side. Our x replaces the base, which are in this case is 8. It replaces the 8 and 8 becomes the base of the log, which is on the right hand side. So let's go a little deeper. So let's go a little further. 9x is equals to 34. X replaces 9. 9 becomes the base of the log on the right hand side. So it becomes log of 9, log with the base 9. Argument 34 is equals to x. Similarly, 12x is equals to 64. Well, let's write it a little much cleaner. X replaces 20. X replaces 12 and 12 becomes the base of the log on the right hand side. So log 12 base 12 and the argument 64 is equals to x. Okay, so that's it for today. I don't want to pump your hair too much. So these are the introduction. This is the introduction of log. Just one thing to wind all of these. Well, basically log with any base of a, which basically it means that any base a could make up a log, or log just with any base a. It's simple. I do not want to get too much into that. Just know that specific bases refer to specific logs. A could be anything. A could be anything except, we have discussed it above, anything except 1 or negative. Well, if it's 10, we refer to it as LG. If it's 10, we refer to it as LG. LG basically means log with the base of 10. Log with the base of 10, if I write it as a short form in LG, it basically means log with the base of 10. It's nothing new. It's just LG, which means or which implies that we are using a log with a base of 10. And similarly, if our base is exponential constant E, so we use ln. So ln basically is nothing. It's nothing new. It's nothing out of the blue. It's just log with the base of E. So I want you to get familiar with this ln and this LG, because in AdMaths paper I've never ever seen them considering log with the base of 10 or log with the base of E. I have just seen them using ln or LGs. So you must know what do LGs and ln stand for. They basically mean, LG means log with the base of 10 and ln means log with the base of E, which means exponential constant. You must know exponential constant. Well, on the calculator you can see it. If I use, well, let me use a different color. Yes, if I use shift and then I use the 10x button, I will reach the exponential constant e. Okay, its value is approximately 2.71 something. It's just, it keeps going on and on and on. So that's it for today. So that's it for just a little bit introduction to logs. I don't want you to get much into this at this stage. I want you to grab it a little by little by little by little, and eventually we'll end up doing logs, and we'll do hard questions too, and we'll do soft questions too, easy questions too, and then you'll recognize, and then you'll see for what it's truly mean. It's a really really easy chapter. It's a really easy chapter. It's a really interesting chapter, and it's a chapter you're already familiar with in O level IGCSEs in the form of indices, but you just didn't know. So yeah, that's it for today. Take care, and I'll see you next time. Assalamu alaikum.